In this video, we will look at an ad hoc problem on permutations, and this problem doesn't really have a lot of techniques that you can reuse in future problems, but this is one of the constructive problems which have been appearing a lot on Codeforces, so it makes sense to try out our hands on constructive problems as well. So let's just start with the problem description. So you are given two permutations. This is permutation P, this is permutation Q. And let's consider two index. Suppose this is I and this is J. J is to the right hand side. So we say that the index J dominates the index I. Index J dominates I if J wins, J is bigger than I on all aspects. That is, J should be greater than I when comparing the indexes. J should be greater than I when comparing the values written in the first permutation, like Pj should be greater than Pi. And J should also win when you are comparing the numbers that are written in the second permutation. So Qj is greater than Qi. Now, if all of these three conditions are satisfied, only then do we say that this J dominates I. If it so happens that the first and second conditions are satisfied, but the third condition is not satisfied, then we say that J will not dominate the index I. So the problem statement says that you are given a third array, call it D, and you need to so you are not explicitly given Q. So this Q was just to help you understand the problem. You are given another array Di, where D of I represents the number of indices that dominate I. So you have to reverse engineer the permutation Q such that for each index I, the number of indices that dominate I is equal to Di. So how do you solve this problem? Now, to solve this problem, notice that for any index I, you are looking at how many index can dominate it. That is, and that value should be equal to D of I. But notice that anything that can dominate the ith element has to be towards the right of the ith element. This means that if we want to lock down the element that you want to put at the ith position, you should at least see all the elements that are to the right of it. Only then you can make an educated guess. And by the way, P and Q are permutations, in case you forgot. So the array that you have to construct should also be a permutation. So now this gives us our first hint that for sure we have to process the elements from right to left fashion, so that by the time you come at this index, you will have the entire knowledge of which elements can dominate it and which elements cannot, because you must have already placed certain Qi to the right hand side. So this is our first observation. Now what is the second observation you can make? And this is actually the crux of the problem. Like in constructive problems, it's all about some observations that you can make, because like I said, it doesn't really contain a lot of techniques that you can reuse, but the ideas, sure, you can definitely reuse in future problems. So let's see, if this is an index I, one thing we know for sure, that if you have constructed this sequence so far, where you are making sure the Di condition for each of these elements is respected. So make sure that Di is respected for each element on the right. So if you can ensure that, then another observation you can make is that when you slide your pointer from I to I minus 1, then the element that was just introduced, it is towards the leftmost element. This is the leftmost element. So this element can never affect the di values of any of these, as long as you do not touch these elements, because the element that was just added, this can only be dominated by elements on the right hand side. It can never dominate any element that you have already seen. This means that once you have fixed everything on the right hand side, as long as you don't touch the elements that you have fixed, you should be good, because you can focus your entire attention on getting the answer for the ith element, and it will not disturb the answer for the other elements. But maybe that is a bit too strict criteria, like saying that you will already fix everything, because you also have to remember that you have to assign the entire thing as a permutation. So you have to use all the numbers from 1 to n. So even without seeing everything on the left hand side, how can you fix everything over here? So maybe fixing every QI that you have found so far is a very tight condition. Can we relax it a bit further? So we know that this newly added element, this will not affect that these elements DIs if you do not touch this, that is for sure. But what is some loose conditions that you can make? So you can notice that if you do not touch the relative ordering between these elements, then also the di will not be affected. For example, uh, if you had, like, let's say you had dis 3 and 5, and then so this is the q array that you have constructed: 3 5 2 1 9 and then 22. Then you can see that even if you increase all of these numbers by 1, for like let's say 6 3 2 10 and then 23, then the relative ordering between these QIs, they do not change. And since the relative ordering does not change, then for every element on the right hand side, if the relative ordering is not changing between these as well as this, like this is also important, the relative ordering between this and this should not change. If the relative ordering is not changing, then their DIs that you have already satisfied, they will remain satisfied. So where do we actually get this idea of relative ordering from? Like, where does the intuition come from? So you will remember that in problems that deal with counting inversions, there, if the problem suddenly asks you to find the number of inversions where the array elements are up to 10 to the power 9, we say that we will use coordinate compression and then we will reduce it down to 10 to the power 5, because whenever the problem talks about j greater than I but aj is less than ai, which is an inversion, we know that the coordinate compression works. So using that as a motivation, you can see that if you can just respect the relative ordering, you don't really need to fix all the QIs beforehand. So now let's try to come up with an algorithm that respects the relative ordering and then tries to create the valid QI for each I that you see. So suppose you are at this index I, and assume that you have already constructed the answer for each of these entries. So you might have assigned, like let's say QI plus 1 over here. So we have not really assigned, but we have decided a relative ordering between them. QI plus 2 over here, QI plus 3 over here. Now for this element, you have to make sure that there are exactly di elements that dominate it. But how do you compute this di? So first of all, the p array is fixed. So this means that given pi, the first thing that you can do is take all the elements that are on the right hand side inside the p array and then sort it. And once you sort it, you will get certain permutation. So pi will be here. This is the relative ordering. All these elements are higher than pi, and then all these elements are lower than pi. So if the total number of elements that are strictly greater than pi, suppose it is s, and then there are some elements which are smaller than pi. Now this doesn't necessarily mean that all the s elements to the right will dominate s, but this does mean that di should be less than or equal to s, because you will pick from the subset of the indices that fall in this range. So suppose you, and that subset is exactly equal to di, so you have to make, so you already have s elements that are satisfying the condition on p. You just have to make them satisfy the condition on q as well. So you repeat the same thing for q. So for q, you already have all these q's, right? So you assume that you have sorted them, and this is their sorted order. So there is some q over here, and you have some elements that are greater than qi, some elements that are smaller than qi. So you need exactly d elements that are greater than, that are strictly greater than qi. So if this is qi, so you need exactly d elements that are greater than qi. So if you have maintained a sorted order of all of these elements, and suppose this is the sorted order, then all you have to do is go ahead and insert qi at the position that will give you d blocks on the top. So you just have to maintain a linked list or a vector, whatever you want, and then you have to iterate over it, and then you have to insert something at the position such that there are d elements higher than it and then the remaining elements lower than it. And if you do this, we have already proved that if you do not interfere with the relative ordering of the QIs that are already placed, then you will not interfere with the DIs that you have already fixed. And in this manner, you can create the relative ordering of all the indices. And once you have the relative ordering, the algorithm is simple. You assign the highest element the value n, and then the second highest as n-1, then n-2, and so on. So you see that like there was nothing fancy in this problem. It was just some observation and then some applications, and maybe not a lot to learn from this, but still a good exercise to solve this problem.